Hello everyone. Today we'll discuss about DFS algorithm, that is depth first search algorithm. This is one of the algorithms which is used to traverse a graph. Let us consider the given directed graph, and on the right hand side we have its adjacency list. Now let us understand how the traversal algorithm works considering the DFS algorithm. Suppose if you want to find out all the reachable nodes from a particular node, then we use a DFS algorithm. In the given graph, suppose we want to find and print all the nodes reachable from node J, including J itself, then one way to do this is to use a depth first search algorithm starting from J node. Now in the first step, what we do is we initially push J onto the top of the stack, and we write stack equal to J. That means the topmost element on the stack is J. In the next step, what we do is that we pop and print the topmost element of the stack, that is J, and then push all the neighbors of J, those are in the ready state. That means those vertices which are not visited. Now if you consider here the adjacency list, the adjacent vertices of J are D and K. So what we need to do is we need to take this D and K and push D and K onto the top of the stack. So we write here stack equal to D and K, and we write print J. Now the topmost element will be K. So the next step, we pop and print the topmost element K and then push onto the stack all the neighbors of K. Those are not in the ready state. Now to check the neighbors of K, we need to check the adjacency list. The adjacency list says that the neighbors of K is E and G. So we push E and G onto the top of the stack and print K. Similarly, in the next step, again the topmost element will be G. We print the G and push all the neighbors of J, that is the neighboring element of J, onto the top of the stack. The neighboring element of G will be, you see here, the neighboring element will be C and E. Now in this step, in the D step, note that only C is pushed onto the stack, since the other neighbor E is not in the ready state, because E has already been pushed onto the stack, because we have already considered E in the previous step. In a simple way, you can say that E is already visited. So that is why we are not writing this E again, and we are writing only C. And again, next step, we pop and print the topmost element C, and then push onto the stack all the neighbors of C. The neighbors of C, those are in the ready state, are, you see here, the neighbors of C is only F. So we write it here F. The next element will be pop from the stack will be F, that is pop and print the top element F, and then push on all the neighbors of F, those are not in the ready state. So in the next step we get print F, that is F will be printed, and what will be pushed on the stack will be nothing, because the neighbors of F, if you see here, neighbors of F is D, and we have already considered D in the previous step. That means the D vertex is already visited, that is not in the ready state. So we don't push on anything on the top of the stack. We say the stack will become D and E. So you need to note down one thing here is that only neighbor of D is F, that is not pushed onto the stack, since D is not in the ready state, because D has already been pushed onto the stack earlier. So in the next step, we pop and print the topmost element, that is E. So we write it here print E, and then push onto the stack all the neighbors of E that are not in the ready state. So if you see here, none of the three neighbors of E is in the ready state, so we don't write anything onto the top of the stack. So we only say stack equal to D. In the next element, we pop the topmost element. Now in this case, the topmost element will be D. So we print D and push all the neighbors of D, which are in the ready state. Now if you see here that there are no neighbors which are in the ready state, so the stack will become empty. So we are not pushing anything onto the top of the stack. So once the stack becomes empty, we stop the algorithm. That is, the stack is now empty, so the DFS algorithm of a graph starting at J is now complete. And accordingly, the nodes which were printed are as follows. So what we need to do is, we need to consider all the nodes which are printed for the reachable nodes. That means, we need to consider all these nodes which are printed. J, K, G, then C, F, E and D. So these are the reachable nodes from the J node itself. And this is called as precisely the nodes which are reachable from J. So this is how the DFS algorithm works. That is, if you want to find out the reachable nodes from a particular node or a particular vertex, then you need to consider this DFS algorithm. As a part of algorithm, there are different steps involved in the DFS algorithm. So we are putting this in terms of algorithm. This algorithm executes a depth first search on a graph G beginning at a starting node A. In the first step, what we do is we initialize all the nodes to the ready state, that is status equal to 1. In the second step, we push the starting node A onto the top of the stack and change its status to the waiting state, that is status equal to 2. In the third step, we repeat the step 4 and 5 until the stack becomes empty. The fourth step is that we pop the topmost node N of the stack, process N and change its status to be processed state, that is status equal to 3. In the fifth step, we push onto the stack all the neighbors of N that are still in the ready state, that is status equal to 1, and change their status to the waiting state, that is equal to 2. And that will become the end of the step 3 loop, and 6th step will be exit. So this is how we write the DFS algorithm as far as the status are concerned.